This video is brought to you by Thermo Fisher Scientific. Offering a wide range of reagents and materials, Thermo Fisher supports virtually every laboratory application, from research to drug discovery and development to manufacturing. With over 80,000 laboratory chemicals now on one site, Thermo Fisher delivers choice, quality, and supply assurance for all your chemical needs. Visit the link below for more information.
He knows a lot about the science stuff, Professor Dave explains.
Earlier in the series, when we introduced a variety of glassware in the chemistry laboratory, we talked a little bit about the purposes intended for each, including volume measurement. Beakers and flasks have volume markings on them like these. We may be tempted to think that this is suitable for measuring 150 milliliters of fluid, for example, but any such measurements will be rather inaccurate because these are approximate values. The width of the vessel means that a small error contributes to a large difference in volume that will be read. Graduated cylinders are much better for measuring volume because the cylinders are narrower and they have more volume markings to minimize errors. However, they also have their limits when it comes to small volumes. Volumetric flasks are another good option for measuring volume because this line here will indicate that, in this instance, you have precisely 250 milliliters, and it's hard to generate a lot of error. But this limits us to just one specific volume. Therefore, we need a more accurate way to measure volumes. Pipettes are perfect for this. We use them to accurately measure a wide range of volumes, from just a few microliters up to tens of milliliters. Pipettes come in different shapes and sizes, but they can be defined as lab instruments which can measure small volumes of liquid in an accurate and efficient manner. They are usually comprised of a tube and an aspirator at the top. You can then stick it in the liquid, aspirate it up to the volume you want, and then transfer that volume to another container by releasing the aspirator. But these can sometimes be very different from one another. For example, in chemistry labs, we like to use glass pipettes like these. They can transfer volumes from 1 milliliter up to tens of milliliters. To use these, we push the top end into a bulb like this. We can then press the bulb to let the air out and keep it pressed. When you then place this in a liquid, releasing the bulb slowly will bring the liquid into the pipette, and you can stop when the liquid reaches your desired volume. You can then transfer this to the desired container and push the bulb to let your measured liquid out. To make this more accurate, we use pumps like these so that you can push slowly. An interesting innovation is these automatic pipettes, which will aspirate and release your liquid with a push of a button. These are great for when you're doing a lot of repetitive measurements in one experiment, since it can get tiring. When it comes to smaller volumes, we use different types of pipettes. The most common pipettes in a chem lab are these disposable Pasteur pipettes, which are great for transferring small volumes. They can have markings on them so that you know how much you're transferring. We also have glass versions of these, since some liquids don't work with plastic. We call these transfer pipettes, and they are not disposable, so be sure to clean them and store them appropriately when finished working with them. As you can see, some of these don't have markings, so we use them to transfer fluid into something that has markings, or to add solutions dropwise, meaning slowly, one drop at a time. A rule of thumb in the lab is that 20 drops from this will give you about 1 milliliter. But as you can imagine, this is not precisely accurate. That's why for smaller scale experiments, especially in analytical chemistry or biochemistry, we use these micropipettes. These can be very accurate all the way down to 1 microliter, and the measurements are repeatable, but they have to be calibrated regularly to stay accurate. These pipettes use the same principle of aspirating the volume and dispensing it. However, with these ones, you set up the volume you want beforehand and attach a special disposable pipette tip. When ready to take up volume, you push the piston down and put your tip in the solution. When you release the piston, the pipette will only take in the set volume, so there is no need to try to stop at a certain volume. To illustrate how to get volume measurements, let's make a standard solution together, which we will use in an experiment later in the series. A standard solution is a solution containing a precisely known concentration of a chemical. These are incredibly important in chemistry because these known concentrations can be used to measure concentrations of unknown substances. Today we will make a standard solution for potassium hydrogen phthalate, or KHP. This is a common acid used in chemistry labs for acid-base titrations. Let's make a 0.1 molar aqueous solution of KHP. To do that, let's weigh 5 grams of the powder and add it to a 500 milliliter beaker. Add a stir bar and about 200 milliliters of water to dissolve the powder. Now, looking at the molar mass, we can do some calculations to see that exactly 250 milliliters of water needs to be added to 5 grams of KHP to make the solution 0.1 molar. So after we dissolve this in the beaker, we will want to transfer it to a 250 milliliter volumetric flask. We can transfer the solution to the volumetric flask using a glass funnel, pouring slowly and carefully. Let's then use a water bottle to clean the beaker so that all of our KHP has been transferred to the flask. To add the rest of the water, we can use a water bottle, but once we start approaching the final volume, we will want to use a transfer pipette to add the last few milliliters. Add water until the bottom of the meniscus touches the 250 milliliter line. You have now made a 0.1 molar standard of KHP. We will frequently be making standard solutions of around this volume in the chemistry lab. Smaller standards can be made by using micropipettes. With this technique understood, let's move forward and see how it can be applied in certain experiments.
Thanks for watching. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. And as always, feel free to email me, ProfessorDaveExplains@gmail.com.